Are you evaluating Legit Security as your next application security posture management platform? In this comprehensive review, we will explain what Legit Security does, how it uses AI, where it fits in a modern DevSecOps program, how it compares to competitors such as Apiro, and the pricing and deployment realities you should expect. By the end, you will know whether Legit Security aligns with your application security goals and your engineering velocity. Let's start with the core problem. Application security today is fragmented across many tools and teams. You may run SAST for code analysis, SCA for third-party libraries, IAC and container scans for infrastructure, DAST for dynamic testing, cloud configuration checks, and secrets detection. Findings land in different dashboards. Developers work across GitHub or GitLab, multiple CI/CD systems, and issue trackers like Jira. Generative AI assistants now commit code that expands your attack surface faster than ever. The result is noise, blind spots, and inconsistent governance across repositories and pipelines. Legit Security addresses this with ASPM, or Application Security Posture Management. Think of ASPM as a control center for your software delivery lifecycle. Legit Security connects to your source control, CI/CD, artifact registries, ticketing, and cloud environments to create an end-to-end map of your SDLC assets and the relationships between them. It inventories repositories, contributors, branches, build jobs, artifacts, microservices, and runtime environments. On top of this graph, it ingests findings from your scanners, normalizes and deduplicates them, and then prioritizes issues based on exploitability, blast radius, business context, and policy. AI is a central design principle for Legit Security. Rather than bolting AI onto legacy workflows, the platform uses AI models to classify vulnerabilities, reduce false positives, correlate related findings, and generate remediation guidance that developers can act on. In a world where AI helps write code, this AI-native approach is designed to identify risky patterns introduced by generative tools, such as insecure library usage, prompt injection-prone code paths, weak validation around model outputs, or leaked tokens in commits and build logs. The goal is to convert raw findings into decisions and actions that reduce real risk without flooding teams with alerts. Integration coverage is critical in ASPM, and Legit Security emphasizes broad connectivity. Common integrations include GitHub, GitLab, Bitbucket, Azure Repos, Jenkins, GitHub Actions, Azure DevOps Pipelines, Circle CI, and Argo for source and CI/CD. For scanning, organizations typically connect SAST, SCA, IAC and container scanners, DAST, and secrets detection tools already in use. On the workflow side, integrations with Jira, ServiceNow, and Slack enable automated ticketing, policy enforcement, and developer notifications. Package registries and container registries help complete the artifact-level picture, while Kubernetes and cloud configuration sources extend governance toward runtime. Key capabilities of Legit Security fall into several categories. First, SDLC asset discovery and security posture. The platform builds an inventory of repositories, pipelines, contributors, and services, and checks them against policies like required reviews, protected branches, signed commits, dependency pinning, and CI job hardening. Second, risk correlation and prioritization. It reduces duplicates from multiple scanners, links issues to the owning repo and team, and ranks them based on business criticality and exploitability. Third, developer-centric workflows. Legit Security can open Jira tickets with enriched context, provide code-level remediation guidance, and give teams dashboards tuned to the languages and frameworks they use. Fourth, policy as code and guardrails in CI/CD. You can define and enforce rules that block risky builds, require SBOM generation, or ensure provenance and signing standards for artifacts. Finally, supply chain security. The platform highlights exposed secrets, vulnerable dependencies, compromised or misconfigured build systems, and gaps in provenance or artifact trust. What outcomes should you expect? Organizations often seek a reduction in alert volume by deduplicating and suppressing low-value findings, faster mean time to remediation through better context and ownership mapping, and improved audit readiness via consistent enforcement of SDLC policies across teams. Security leaders look for measurable improvements, such as fewer critical vulnerabilities reaching production and demonstrable governance over AI-influenced code contributions. How does Legit Security compare to alternatives? Apiro is a notable ASPM competitor with strong SDLC visibility and risk prioritization. The differences can hinge on integration depth with your exact toolchain, how each platform models your SDLC assets, and the developer experience for remediation. Teams also consider platforms from vendors like Snyk, Checkmarx, JFrog, and cloud security providers such as Palo Alto Networks or Wiz when they need broader code-to-cloud visibility. Your best approach is to build an evaluation matrix that scores coverage of your repos and pipelines, noise reduction effectiveness, ticket automation, policy authoring and enforcement, AI-assisted triage quality, and time to value and pilot. Implementation typically begins by connecting to your source control and one or two CI systems, then progressively adding scanners and ticketing. Early wins come from SDLC hygiene checks, such as enforcing protected branches, code review rules, secret scanning, and consistent build hardening. Next, teams enable correlation across SAST, SCA, IAC, and container findings, align ownership to teams, and roll out automated Jira workflows. Finally, organizations adopt policy as code to block risky releases, require SBOMs, or validate artifact signing and provenance, folding these controls into existing development practices rather than creating parallel processes. A frequent question is whether legit security replaces existing scanners. The short answer is no. ASPM is designed to orchestrate and elevate the scanners you already rely on. Its value is in visibility, correlation, prioritization, governance, and developer experience. Another common question is how it handles scale. The platform emphasizes enterprise-grade integrations and normalization, but you should test against your largest repos, busiest pipelines, and peak commit windows to validate performance and ensure alerts route to the correct owners without lag. Pricing considerations vary by organization size and scope. Factors often include the number of developers, repositories, and pipelines under management, integration breadth, data retention, and support level. Many customers start with a proof of value to confirm coverage and ROI, especially to quantify alert noise reduction and the impact on remediation times. Include success criteria like percentage reduction in duplicate findings, SLA adherence for critical vulnerability remediation, and the number of policy violations automatically prevented in CI/CD. Security and compliance teams appreciate audit-ready reporting. Legit security can help demonstrate that required controls are in place, controls are consistently enforced across teams, and exceptions are tracked with approvals. For regulated industries, the mapping between SDLC controls and frameworks such as SOC 2, ISO 27001, or NIST guidance can accelerate audits and reduce manual evidence collection. Finally, consider the developer experience. The platform's adoption depends on whether engineers see fewer low-signal alerts and receive precise, actionable guidance in their tools of choice. Integration with pull requests, code reviews, and issue trackers should feel native. Look for clear ownership mapping, links to relevant commits and builds, and remediation steps that are language and framework aware. This is where AI can change the experience, not just flagging a problem, but proposing a pragmatic fix path that respects your coding standards and deployment practices. In summary, Legit Security offers an AI-native approach to ASPM that unifies SDLC visibility, reduces alert noise, and enforces governance in the pipelines where software is built. It is a strong fit for teams wrestling with fragmented tools, rapid release cycles, and AI-assisted development. Compare it head-to-head with Apiro and evaluate it alongside code-to-cloud platforms if you also need runtime context. Validate integrations, measure noise reduction, and ensure the developer workflows meet your teams where they work. If those boxes check out, Legit Security can be a meaningful addition to your application security stack.